All right, so what we're going to talk about today is a thing in physics called kinematic equations. So whatever I write down, you guys write down. And the kinematic equations are the physics equations that we're going to use for the next month or so. And it just helps us measure and calculate motion in one dimension, and then we'll ramp it up into 2 dimensions. But the 2 dimensions, we're just separating it in the x and y direction. So I'm going to write down the x stuff, but the y stuff is the same, except instead of x, you would write down y. Can somebody get the door real quick? So one of them, and I want to talk about a couple of things. Lowercase f in many cases means final, and an I means initial. And in the notes, sometimes that'll be written as either a 0. Sometimes the initial is called not. But we'll just write these down. So my final velocity is equal to the initial velocity plus acceleration times time. So v is equal to velocity. And some of this you might have written down already. A is acceleration. And T is time. And also remember that the Greek letter delta just means change. It's an incremental. And it usually means the final minus the initial. So this is one equation. Another equation that we have is that delta x, the change in position, is equal to, in parentheses, v final plus v initial squared. No, they wrote that wrong. It's actually 1/2. So, oh, I see what they did. Delta x is equal to 1/2 times v final plus v initial times time. Another equation is going to be delta x is equal to the initial velocity times time plus 1/2 times the acceleration times time squared. And the last one is the one we're going to use today, which is going to be v final squared is equal to v initial squared plus 2 times delta, 2 times the acceleration times delta x. And one last thing we should probably write over here is that g is the acceleration due to gravity, and that's negative 9.8 meters per second squared. And so when we shoot this thing out of the cannon, what I really want to know is and I need to know this initial velocity here, right? That's what I really need to know, is the initial velocity. How fast is this thing coming out of the cannon? All right. So what you don't realize is that we kind of know a lot of information. So when I shoot this out of the gun, delta x is going to be delta x. Whoops, let me change that. Delta x is actually, we're going to change that to delta y. And this is going to be our average max height, which we will calculate in a second. That's how high it travels up, right? And like I said before, delta y, delta x. Anytime there's an x, we can replace it with y. Now, A is going to be replaced with G, okay? And then right when that bullet gets to the maximum height, that's our final velocity. So what does it do right before it falls down? It stops. So our final velocity is going to equal 0 meters per second. So what we're going to do then is we're going to say 0 is equal to the initial velocity squared plus 2 times g. And actually what we could do is we could toss, because it has a negative sign, we could toss the negative sign to the front, but we'll deal with that in a little bit, okay? Times delta y. And since I'm going to deal with all this stuff, I want to solve for vi, which is the initial velocity. So I'm going to subtract 2g. Now we're going to do a little algebra. 2g times delta y from both sides of the equation. And this is a very, I don't want to say famous equation, but it's a well-used equation. So now I have negative 2g times delta y is equal to vi squared, but g is negative, so I could think of this as negative 2, and oh, I want to get the square root, right? So it's going to be square root of 2 times g times delta y equals vi. Now, where you've got to remember that g is a negative 8, because that negative times this negative makes it a positive, okay? And this is how we're going to find our answer, okay? Can somebody get the door real quick? I'm kind of recording. All right, so now what does this mean? Well, we're going to go back and use this formula to calculate some things. So the first thing I need to know, and I'll wait a second until everybody has that written down. Why is there, oh, the pole's in the way. Can you just lift the pole up and take it out? Okay. So real quick, what we're going to do is we're going to go back and look at our desktop. And I'm going to find the average. So you should have, every one of you guys should have like 2 decimal places. So if the meter sticks at 35 centimeters, remember you have to convert that to meters. So it'd be 0.35. So double check your spreadsheet real quick. And by the way, the recorder, if they're here today, only one person, if you shared it with everybody in your group, only one person needs to put in this formula that I'm about to say. So to find the maximum height, so first make sure that you have your numbers right. Okay. Then the next thing you're going to do is to put a formula in here. I'm going to hit the equal sign, and I want to take the average of B. And if you notice, it automatically says average, right? So we're going to put that formula in, and this is the formula here. I don't know if you guys could see that in the back. I could zoom in a little bit if you'd like. But you're going to say the average of B2 to B11. And what that's doing is it's going to take the average of all this stuff that's highlighted. Okay, you literally type out the word average and then parentheses B2 colon B11. Okay, I'll give you guys a second to get that done. Then the next thing you're going to do is when you hit enter, it'll automatically calculate your average maximum height. Not mine, yours. So now the max height speed is 0 at the top, right? So it starts off here with an initial velocity, goes up high, and then it slows down. So you just type in 0 here. Now the acceleration due to gravity, as we said, was negative 9.8 meters per second squared. Now to find that initial velocity, I'm going to plug in the following formula. Are you guys ready? Equal sign. I'm going to type SQRT, That's for a square root. Okay. Then I'm going to say -2 times. I'm going to multiply that by this number. So I just click here, which is C6, times the average maximum height, which is this one up here, my delta y. So when you're done, it should say equals SQRT, open parentheses, -2 times C6 times C2. Okay, I'll leave that up there for a second. And we will hit enter. Now your initial velocity should be pretty close to about 3 meters per second. Anybody got something very way off from there? 3 meters per second. Anybody got something way off? Okay. You're all about 3 meters per second roughly? Is there anybody that's got like a 5 meters per second or 4 meters per second? What do you guys have? Yeah, but yours was shooting up high, right? So keep this in mind. If your group had to use 2 meter sticks, you'll be closer to 5. If you could do it in 1 meter stick, you'll be around the 3 range. Okay? Any questions on that so far? So now we're almost done. Now what I want to do is I want to predict. Yes? What do you mean the time part? This one? Well, really what we did is we plugged in the values. So it's actually this formula here. Let me pull this up. It's actually this formula here. It's this formula here. Actually, it's just this part of the formula. So we're solving for this. So it's -2 times the acceleration due to gravity times the maximum height. But to do it in the spreadsheet, what we did is we said the square root of -2 times g, which is the acceleration due to gravity, which is in this cell right here, C6, times the average maximum height, which is this. Does that make sense? Okay. Cool. Any other questions before we move forward? All right. So now, see how it says sheet 2? Real quick, everybody measure the height of your table with a meter stick. You grab another meter stick. Leave the ones that are taped up. Come grab another meter stick and measure how high